Today we're going to use similar triangles to explain slope. You should be on page 56 in your notes packet. When we talk about slope on a graph, that is the steepness of the lines on a coordinate plane. To find slope, we look at the ratio or the fraction of vertical change over horizontal change. When you look at this part, this is the most important thing on your page to show you how you find slope. Slope is usually referred to as the variable m. And to find slope, we usually do rise over run. Rise represents the vertical change, so how far up or how far down it goes. If it goes up, that is a positive change. And if it goes down, that is a negative change. The run represents the horizontal change. If we have something that goes to the left, then that is a negative horizontal change. And if we have something that goes to the right, then that is a positive horizontal change. Now we're going to look at these similar triangles and we're going to prove that they are similar using slope. So let's start with triangle ABC. In order for triangles to be similar, we know that all of their side lengths have to be proportional to each other. Well, we can use the slope of this long line that they are all on to prove this. So I would find the slope of the line for AC. Well, I'm going to ask myself, how would I get from A to C? Well, if I started at A, remember slope is vertical change over horizontal change, or rise over run. Well, from A to C, I would have to go down, and if I counted, I would go down 1, 2, 3, 4 units. Because that is a change going down, that's going to be a -4 for my rise. Now, that would put me right here, but I'm not at C yet. So to get from here over to C, I would have to move right 1, 2 units. Because I moved right, then the horizontal change here, or the run, is positive. So that would be a +2. Well, if I do -4 divided by +2, I'm going to get -2. Now we can look at triangle DEF and see if that is the same. So let's find the slope for the line segment that goes from DF. Again, we're doing rise over run. So we're trying to get from D down to F. Well, if I start at D, first I would look at my vertical change. So I would have to go down to get to F. Well, I would go down 2 units, which gives me a rise of -2. Now that would only put me here at E, but I know that I need to get to F. Well, to get from here to F, I would move right 1 unit. So because I'm moving right, that's a +1. Well, if I do -2 divided by +1, I get -2. Well, you'll notice that even though my triangles looked different, the slope of this part of the triangle, or the hypotenuse of the triangle, is actually the same. Now, remember, slope is not the same as the distance between points. Slope is just how steep the line is. So these would have a steepness of -2. Number 1 says write a proportion comparing the rise to the run for the similar slope triangles and determine the numeric value. So what this really is saying is, what is the slope of these triangles? Well, if I look at E and F, I'm trying to get from E really down to G, because I can see that there is this one line that both of these triangles are part of that goes all the way from E to I. So if I looked at E and I needed to get to G, I would have to look at rise over run. So I would go down 1, 2, 3, 4 units. Well, that gives me a -4. And then I would have to go right 1. So that would give me a run of +1. Well, -4 divided by +1 gives me -4. So the slope of this triangle is -4. Well, since these are on the same line, I really should have the same slope for both of these. So let's look at triangle GHI. To get from G to I would have to go down 1, 2, 3, 4 units. So that would again be -4. Then I would have to go right 1, so that would be +1, which would give me a slope of -4. So this triangle also has a slope of -4. Number 2, write a proportion comparing the rise to the run for the similar slope triangles and determine the numeric values. Well, when you look at this, it looks like you don't have two triangles, but you actually do. So you have the first triangle, which is the large triangle that you see, and that is triangle JNL. Well, the slope is going to be this line that goes from J to L. So let's figure out what that would be. So again, we're going to do rise over run. Well, to get from J to L, I would have to go down 1, 2, 3, 4, 5, 6. So that is a rise of -6 since I went down. Then I would run to the right 1, 2, 3, 4, 5, 6, 7, 8. Because I went to the right, that is a +8. Well, I would want to simplify that. And I would not want to simplify that to a decimal. I would just want to put it in a fraction in simplest form. Well, 6/8 can be simplified to 3/4. So this is going to have a slope of -3/4. Now let's look at the smaller triangle. So the smaller triangle here is triangle KML. So we're going to find the rise over run for this to figure out KL because we notice that that's the line that both of these triangles share. Well, if I go from K to L, I'm going to start with my vertical change. So I would go down 1, 2, 3 units, which gives me a rise of -3 because I went down. Then I'm running to the right, so that's going to be +1, 2, 3, 4. Well, since this is -3 over +4, that cannot be simplified. And you notice that even though those triangles looked different, they have the same slope. And that's because this line is the same and it's changing at a constant rate everywhere on the line. For number 3, we're going to graph the ordered pairs of these similar triangles. So QRS is at 1, 6, so that's right 1, up 6, so we're going to label this as Q. R is at 1, -6, so we're going to label this as R. And then S is at -3, +6, so that's left 3, up 6, so we're going to label this as S. So we're going to combine or connect these points. Then let's do W, Y, and Z. So W is at -1, 0, so that's right here. Y is at -1, -3. And then Z is at -2, -3, which is right here. So we have this triangle right here. So it looks like they don't share a line, but they actually do. This part of the line right here is shared by both of these. So if I wanted to find the slope, then let's find the slope that goes from S to R first. Well, if I'm trying to get from S to R, you'll notice if I do my rise over run. To get from S to R, I would actually have to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units. So that is a -12 for my run. But then I would still have to go right 1, 2, 3, 4 units. So because that's right, that's a +4. And if I do -12 divided by +4, I get -3. Now let's look at the slope for WY. Again, we would have to do rise over run. So to get from W to Y, if I started here, I would have to go down 3 units and then left or right 1 unit. So that's -3 over 1, which gives me -3. So because of that, this is going to also have a slope of -3. For number 4, We have negative 6, 5, so that's left 6, up 5. That's going to be E. Negative 6, 2, that's going to be F. And then negative 2, 2, that's going to be G. Then we have G again, negative 2, 2. Then H is at negative 2, negative 4. And then I is at 6, negative 4. So you can see that these share this line that goes right here. So if I wanted to find the slope, we would start with EG. Well, to get from E to G, we would go down 3 and then right 4. So that's a rise of negative 3 and a run of positive 4. That can't be simplified, so we would leave it just like that. Then for our other triangle, we would find the slope that goes from G to I. Well, from G to I, we would have to go down 1, 2, 3, 4, 5, 6. So that's a negative 6. Then right 1, 2, 3, 4, 5, 6, 7, 8. So that's a positive 8. Well, 6 and 8 simplifies to 3/4, and we have to remember that that was negative. So we can see that because they were on the same line, they share the same slope.